Hi students, welcome to physics classes. Today we'll discuss determination of specific heat of solids. Determination of specific heat of solids, lab activity. 10th class physics lab activity. Find specific heat. We should find the specific heat of a given solid material. We should find the specific heat of given solid material. Whatever the solid they given, we can find the specific heat of it. To do that experiment, we require materials required: calorimeter, thermometer, stirrer to mix, water, steam heater, wooden box, and a solid material for which we want to find specific heat, either lead shards or iron bolts. Whatever they given solid material, for that we should find the specific heat. Now first we should take a calorimeter along with stirrer. We should find its mass. We should measure its mass. Let us take M1. Now fill that calorimeter 1/3 of the volume with water. After filling water, again we should measure its mass and temperature. Now its mass, calorimeter, stirrer, water. Total is calorimeter, stirrer, water. Its total mass is M2. If we want only water mass, we should remove calorimeter plus stirrer. So M2 minus M1. Only mass of the water. M2 minus M1. Now we can measure the temperature. It is T1. Temperature T1. Now water is in the calorimeter. So water and calorimeter both are having same temperature. Water, calorimeter both are having same temperature. That is T1. Now we should take a solid material for which we want to find the specific heat. Solid material for which we want to find the specific heat. That solid material we should take, and with the help of steam heater we should heat it up to a higher temperature. Let us take that high temperature T2. High temperature is T2. Now transfer this solid material into the calorimeter. Already calorimeter contains water. In that we should add solid materials, whatever we want to find the specific heat. Now after adding the solids, heat will be exchanged. We can stir it with the help of a stirrer. Now heat will be exchanged. So final temperature of that we can take T3. Now again measure mass. Mass of the calorimeter with its contents. What are the contents in that? Calorimeter, stirrer, water and solid material. That we can take M3. Now if we want only mass of the solids, we can remove the remaining. Remaining mass is M2. Calorimeter, stirrer and water mass is M2. After adding solid material, it becomes M3. So M3 minus M2, then we can find the mass of the solid material. Now let us assume specific heat of the calorimeter SC and specific heat of water SW. and the specific heat of the solid material, whatever we want to find specific heat, that we can take SL. As in our textbook they given lead shots, we will take it is SL. Specific heat of solid material, lead shots, SL. Now, after adding that solid material into water, heat will be exchanged. Let us assume no surroundings absorbs the heat energy. No surroundings absorb the heat energy. So, net heat lost by the hot body equal to net heat gained by cold body. Heat lost, Q lost equal to Q gained. Heat lost by, if no surroundings are absorbing heat energy, Q lost equal to Q gain. Heat lost equal to heat gain. Now Q formula we know, amount of heat equal to ms delta T. Q equal to ms delta T. Q amount of heat, mass of the substance, specific heat, change in temperature. Now Q lost, solid material will loses the heat energy. As it has more temperature, it will lose as the heat energy. Which will gain? Water and calorimeter. Heat gained by water plus heat gained by calorimeter. Now Q lost, solid material, mass of the solid m3 minus m2, specific heat of solid SL, change in temperature. Change in temperature, we should take higher temperature minus lower temperature. Initially solids, after heating with the help of steam heater, it has high temperature, that is T2. After adding to the water, it loses some of its heat energy and becomes T3. So initially it has more temperature, after losing something it becomes T3. So higher temperature minus lower temperature equal to heat gained by water, ms delta T, mass of the water, m2 minus m1, specific heat of water, SW, change in temperature. So these two are gaining the heat energy. Initially it has less temperature. After gaining something, it becomes T3. So T3 is a higher temperature and its initial temperature is less T1. Higher temperature minus lower temperature, T3 minus T1. Next, plus heat gained by calorimeter. Mass of calorimeter M1, specific heat of calorimeter SC, and temperature. Water and calorimeter both are having same temperatures. Now initially it has low temperature, after adding something it becomes higher temperature. So higher minus lower, T3 minus T1. Generally students will be feeling up to here it is easy. After this substitution calculation they will feel difficult. But this is only easiest one. Substitution only easiest one. Because already everything we derived previously. Mass of solid, specific heat of solid, and change in temperatures. Like that for water and calorimeter also we derived earlier. Now we are substituting there. Now simplification. Here we should find specific heat of the solid material, SEL. So this is as it is I am writing, M3 minus M2 SL, no change here, T2 minus T3 equal to, here in this T3 minus T1 I am taking common. So if I take T3 minus T1 common, then what is remaining? M2 minus M1 into SW plus m1 into SC. Here entire we have taken common, no, this one, so brackets. These brackets are very important. If you forget one bracket also, its meaning will be changes. So we should remember these brackets. Now this specific heat of solid we want, SL I am keeping here, equal to T3 minus T1 into M2 minus M1 into SW. This is one term, plus M1 SC. This is another term. This one term, this is another term. This M3 minus M2 into T2 minus T3 coming this side, divided by minus T3. This is the formula to find specific heat of solids. In the book they given SL, specific heat of solid, equal to, first they written this M1 SC plus this one M2 minus M1 into SW for whole multiplied with temperature T3 minus T1 divided by M3 minus M2 T2 minus T3. This is the required formula, which is very important in the point of public exams. Thank you for watching. Please subscribe.